Well, it's really cool to be here. It's my first time in a cool studio like this, so first thanks for the ability to speak here and this platform. So today I want to take you through how to get the best user experience for 3D workloads with Citrix. And Esther, you might know where this picture is taken. Can you see this? What's on my screen? Do you know where this is?
I think it's the Afsluitdijk.
No.
Then it's next to from my hometown.
To my hometown.
Yeah, I was going to say that.
Yep, I was looking through our stack of images that we can use at Citrix for presentations, and I found an image that is 5 kilometers from my house. So that's my intro slide. There you go. Let's see if it still works. No, it doesn't. Sorry for this. Yeah, you broke it. Oh no. Yeah, that's. Is it working now or?
Yes.
I don't see anything.
There you go. There you go.
But I'm way too more. It's.
Spoilers.
Yeah, spoilers. Sorry for this. All right. There we go. Something went wrong here. So my name is Rody Kossen. I'm a senior principal quality engineer at Citrix. And for the people who don't know where I live 4 meters or 13 feet below sea level. And the windmills that you saw, those are close to my home. Here you can see a picture. That's just a walking distance from my home. But yeah, I'm almost with my feet in the water. But that's not what I'm going to talk about today. Today, I want to talk about user experience. That's all we're going to talk about. Because you want to be on the left side of this picture. You want to be happy, you want to work, you want to be able to do things smoothly, and you absolutely don't want to be the guy sitting there on the right with his fingers and is pulling out his hairs like, this is crap. So that's why we're going to talk user experience and how to optimize it. All right. Like I said, I work for Citrix, and within Citrix we have something called HDX, which stands for High Definition Experience. And that contains of a lot of items like graphics, audio, video, collaboration, but today I'm going to focus on graphics because it's Team Remote Graphics Experts, right? Wow, my touchpad is really tricking me. All right, so let's go into graphics. And before we start going through the graphics stack, let's start first with video codecs. Because it's an important part of a remoting protocol. And video codecs are very common. So you would see them in, on YouTube, on Netflix, on the remoting protocol. Basically, every vendor today out there uses some form of video codec to enhance their protocol. They are heavily optimized to reduce bandwidth of moving images. So remind the moving here. I'll come back to that later. And they're pretty old as well. If you look at H.264, which is one of the most common codecs, it was released in 2003. H.265, the successor, 2013. That's 11 years ago already. And then we have the latest and greatest AV1, which is already there for more than 5 years as well. Like I said, H.264 is the most common one out there, and therefore many devices support it. It's basically supported by every device that you probably have at home. It's a good codec, but like I said, it was released in 2003. Did they ever think about high-resolution screens like 4K? Did they ever think about HDR? So HDR, 10-bit color, high dynamic range. I couldn't find the word. So that's why there are newer codecs today as well, like H.265, which is very common these days on Blu-ray discs. There's also very broad support for hardware and encoding and decoding. Because it's a better compression mechanism, it also means that you need more horsepower to encode and decode it. That's why it makes sense to look at hardware acceleration. And that's also why CPU decoding is very costly. Like I said, there's a new kit in town, AV1, which is one of the latest generation codecs that's available, and it starts to become more and more common as well. Many services are starting to migrate to AV1 because it's newer. It's also much better in terms of compression, so it has superior compression compared to the earlier codecs because it was created with high resolution screens in mind. So it's made to compress high resolution data much better than the previous ones, but that comes at a cost, and that cost needs to be filled by hardware. So AV1 is really a codec where you need hardware encoding and decoding to get real-time performance. Here in the table you can also see what generation of GPU you need for encoding and decoding, because today Citrix supports this in our product. So we have support for AV1 in product since a few releases now. So we added it for NVIDIA in the 2305 release, and in the 2308 in August last year we added Intel support. We support it in all our different options, and I will go through them a bit later on. Well, you ask, why would you support AV1? And why should I use it? Well, if we compare the bandwidth utilization for AV1 to H.264, we can see a significant decrease in bandwidth. So if you look at this table that's here on the screen, you can see that compared to H.264, H.265 already on low quality already saves you 46.5% of bandwidth. But if we step to AV1, we can see 56%. So that's half of the bandwidth for low quality. If we go up to high quality, it's even more significant, 36%, where H.265 only does 3 to 10%. So on high quality, you need 36% less bandwidth. So if you think of it, if you have a low bandwidth condition, so you're working from anywhere, you might not always have the highest bandwidth available. So with AV1, you can get much better quality at the same bandwidth level. So that's a really big win, if you ask me. And seeing is believing. There's some compression artifacts here going on, but I hope it's visible for you. But if we look here at the bandwidth consumption, this is H.264 is at 22, 23 megabits peaking. On average, it's 14, while the AV1 is just 8 on the same quality. And I say the same quality, but sometimes most times AV1 even gives better quality. So if we use the lowest quality level of H.264, you can see a lot of artifacts happening. And if we zoom in, there are some details that you can see here. So here on the car, you can see there's compression artifacts. Here next to the pillar, there's some compression artifacts. If we look at AV1 on the same quality level or the same bandwidth, oh, there's something going wrong with the connection, I think. All right.
We'll skip the picture.
We'll skip the picture. So what I want to show is that with AV1, you can't see these artifacts. So it's lower in bandwidth, and also it's just much higher quality. Another important aspect, and I will go quickly through this because we lost some time, is chroma subsampling. So chroma subsampling basically removes color information from the video stream, and its only intent is to lower the bandwidth. So the amount of data is being lowered by taking out color data, because our eyes are not that sensitive in moving images for this color information. So we keep all the brightness, the Y, but we remove some UMV data here. So the most common one out there that's used, YouTube, Netflix, all use them, is 420, and no compression means 444. this is an important one because if you have chroma subsampling active, it could give issues with still images, and especially if you have sharp contrast between different colors. For example, here we can see that with YUV 420, the blue and the red start to blend into each other, while with 444, if there's no color compression, you can really see the sharp lines. So even though 420 doesn't make any, it doesn't make any sense if you have, or doesn't make, or it doesn't give you any issue if you have a moving image. With still images, it gives issues like this. All right, so enough about video codecs, and let's talk policies, and let's see how can we optimize this user experience with the different settings that we have. So I think everybody here wants to get the best user experience in most scenarios, right? Shall I give you the best policies for that? We're done. I will thank you for my session, and all right. No, all jokes aside, out of the box, our policies are tuned for 95% of the use cases. Only in specific use cases I would change the policies, but I would always recommend starting with the default, see how that behaves with your application work set, and then switch over to fine-tuning and tweaking these policies. Because the default already, like I said, covers most of these scenarios. But let's do a deep dive so you understand which policy does which thing. So let's start at the top level of our policy sets. And that's the policy called use video codec for compression. Well, that already says something what it does, but it doesn't really fully cover what it does. And I'll explain you. So we have 4 different modes here called use when preferred, which is our default setting. For actively changing regions, do not use video codec, and for the entire screen. Well, some of them already tell you what it will do. So for example, for the entire screen combined with video codec will give you a direction what we're doing. But for actively changing regions, what does that mean? So let's take a look at a typical screen, right? So this is an overview of a YouTube page where you can see the YouTube video and a lot of content around it. Because if you go to a web page, it's not only a video, there's also other things happening. So we can see text, simple images and solid colors. And in this case, they're highlighted by a blue line. We have static image content, which are the logos here, the old Citrix logo, the subscribe button. Those are static images. And then we have a moving, or what we call transient or fluid image, and that's the actual YouTube video. So these are the different segments. And I'll tell you which policy actually does what kind of compression to these elements. So if you would select use video codec for compression, and you would set it to for actively changing regions, then we would use RLE, which is a lossless encoder for text, because text, like I said, with the 420, 444 example, you want to have the best quality there. You don't want to have colors blending into each other. So text is encoded with a lossless image. We also use RLE for simple images and solid colors. Static images are compressed with the JPEG encoding, and the moving image, the YouTube video, will be compressed with a video codec. So that's why we call it for actively changing regions, because if a region is actively changing, we will start using a video codec, which will optimize the performance for that particular section on the screen. We also call this our selective mode. Secondly, on the right hand, we have something called the do not use video codec, which is roughly the same as the for actively changing regions. The only difference is that for the moving images, we don't use a video codec, but we use adaptive JPEG, which could help you in situations where you don't have a GPU available, or you don't have high frame rate moving images, and you want to keep the CPU consumption low. And like I said, we can detect what's happening on the screen, and you can also see that with our status indicator. So on the left hand, if you launch a session, you would first see that we didn't detect any video yet, so the video codec is currently inactive. the hardware encoding is enabled, but it's also inactive. And once we detect a fluid image, we switch over that area to a video codec. So in this case, AV1 with YOV 420, and we do that on hardware encoding on the GPU. So we can flip in and out of these modes automatically. Another option that we have, and that's also known as HDX 3D Pro, is for the entire screen. And what does it mean? Well, text, simple images, static images, and moving images are all encoded with a video codec. So basically, we encode the entire screen with a video codec, which can be H.264, H.265, or AV1. So that's basically the set that you can choose from. Well, then we have one mode left, right? The use when preferred. So what does that do? Well, with use when preferred, you go into our default mode, and it will be the same as for actively changing regions if you do not set optimize for 3D graphics. If you do set that, it will switch over to for the entire screen. So basically, it's our default mode, and we can switch back and forth between different options. So I would recommend in most use cases to keep this as the default. All right, secondly, after you've set the that first policy, we want to also take a look at the visual quality. So we have 3 different modes by default called high, medium, and low, which basically describe already what they will do. And they affect the JPEG quality levels of static images and moving images in the selective mode. It will also set the quality of the video codec in the selective mode. But it does not have effect in for the entire screen. In the for entire screen, we set the quality automatically based on whatever bandwidth we have available. Next to the high, medium, and low, we have 2 different options available as well, called always lossless and build to lossless. So let's go into these 2. So always lossless gives you a pixel perfect quality. And with pixel perfect quality combined with for actively changing regions or do not use video codec, we use RLE instead of the JPEG or video codec. So basically everything is encoded with a lossless encoder. If we have for the entire screen enabled, you need to set allow visually lossless as well, which will switch, if we go back to what we've learned before, to YOV 444 instead of 420. So that comes at a cost of bandwidth, because we don't compress the colors, but it will increase the quality significantly. And we support today H.264 444 and H.265 444, and especially the last mode is pretty important. And I'll come back to that later. But bear in mind, this really sounds cool, right? I want to have the best quality. I will set always lossless. But it takes a significant amount of bandwidth to send this over. And it can also have an impact on interactivity and user experience when there is not enough bandwidth. Because in always lossless, we can't drop the quality. So normally, in a normal mode, if the bandwidth would drop, we can drop the quality as well, so you can keep that interactivity. But with always lossless, we need to send over a lossless image, so that will reduce the frame rate. If you use the allow visually lossless for higher frames per second, then you need to have a GPU in the VDA. And if you want to have the best performance in that mode, you should use H.265 444, but that needs dedicated hardware as well. So I've listed the hardware here that you need on the encoding side and also on the decoding side. So we need to have for NVIDIA, for example, a Turing GPU in the client and a Pascal generation or newer on the VDA. So why am I hammering on H.265? Well, here you can see the difference between software encoding and hardware encoding. So this is playing a 4K video, a YouTube video full screen, a video called Costa Rica 4K, which is a really lovely video, by the way. You can see that we're hitting the 60 FPS mark. There are some drops here, but that's more due to the scene, because it's really hard for the encoder to encode that scene due to the complexity and the amount of bandwidth needed. But if you look at this, you can see that we're hitting 60 FPS, what we requested. While with H.264, which is software encoding, we're doing between 10 and 20, and that's really depending on your CPU as well. So that's why it's important to look at these new codecs. All right, so we've looked at always lossless, but what's built to lossless then, and why should I use it? Well, built to lossless is a unique mode, and it's basically a balance between pixel perfect and bandwidth consumption. So we try to balance between those two to give you the best interactivity as well. And it combines a full screen video codec with a lossless sharpening. So basically, if you move something on the screen, it will do a video codec. Once you stop moving, we will encode that entire frame with a lossless sharpening frame. And if you combine that with the option allow visually lossless, we can go into a mode called build to visually lossless, where we will use the 444 option. And we can do that in 8-bit and 10-bit and even with HDR. Which means that with the allow visually lossless combined with build to lossless, we can still adapt that quality. So if there's not enough bandwidth, we can lower the quality of the image while you move it. And then once you stop moving it, we will build up to a lossless image. So how does this work, or what does this look like? I hope that this works on the screen. Yep. So this is built to lossless on a AutoCAD file. And you can see once I zoom in, you can see some artifacts. But once I stop moving, you can see that it builds up automatically to a lossless image. So that's a really powerful feature. We also enhanced that in a recent release, because previously the build to lossless happened from the top left corner to the bottom right corner. But the user is mostly looking at his mouse, right? So it makes sense to build up this image around the mouse. So if you can see my mouse cursor and I'm not moving anything on the screen, I'm clearing up these artifacts. And bear in mind, I lowered the quality here to show the effect. Normally you would probably not see this, only on very low bandwidth conditions. But if you would put your mouse somewhere on the screen as well, it will start to build up from that position outwards. So build to lossless really gives you better interactivity than always lossless, and that's why we recommend, if you're looking into these modes, if you have the need for a lossless image or this high-end quality, please use this mode because it just gives you a better balance and a better performance. All right, so another policy that's important for the user experience is the target frame rate. And basically it tells you how much frames per second we're outputting at the maximum. The default is 30. You can set it from a range to 1 till 60. We have tricks to set it up to 120, but that's not recommended for most use cases. If you have that use case, feel free to reach out to me. But be aware, it sounds really cool to set a really high frames per second, but it can also have a huge impact on the performance of your hardware and your density. So if you would set a very high frames per second, you need more encoding capabilities, you would use more resources, so that impacts your scalability, which then also could impact your user experience. And also bear in mind that if you use NVIDIA vGPU, they have limits that you need to disable. By default, I think they limit up to 60, depending on your GPU profile. So you should check that if you want to go higher than a certain level. There's one additional option that I see quite a lot in the field that people are setting. It's called the display memory limit. That's an option that's only needed for non-GPU scenarios. So you don't need to set this if you have a GPU in your system. And also we made it even simpler. Starting in 23.11 release, it's deprecated, and we just set it to the highest level that's necessary for your setup. So don't set this if you have a GPU, it doesn't do anything. All right, I hope I have still time because we went to so many options. So let's go into a few use cases and how to set it up, basically. All right. Like I said before, I would recommend the default policy set for most use cases, and especially if you have an office worker or, well, there are a few developers here probably in the room as well. If you work with a lot of text, out-of-the-box experience will give you the best option. So use video codec for compression, set to use when preferred. The hardware encoding can be left to enabled, so if you have a GPU, we can leverage that. Set the visual quality either to medium, which is the default, or to high, and keep the target frame rate at 30, which is high enough. So like said, this is just our default policy. For financial traders, a setup like this, believe it or not, default. Out of the box, you will get the best experience with our default policy set. We also wrote a quite extensive blog article on how to set it up, also on the client side, and a few tips and tricks. How to set it up for so many screens. So it's really interesting if you are working for a financial company to look into that. But out-of-the-box experience is the go-to option here. 2D CAD. So if you work with Autodesk, AutoCAD, or any of the other 2D workload tools, I would recommend to set the use video codec for compression to use when preferred. You should have a GPU with CAD software, so enable hardware encoding. Set the visual quality either to high or build to lossless. Target frame rate 30 should be enough. Maybe some use cases require 60, but AutoCAD is not really a high FPS workload, if you ask me. And also we had that option of allow visually lossless. I would start with keeping that disabled, but you can set it to enabled. And I added an asterisk for the visual quality and the allow visually lossless, because it really depends on your use case and your end user requirements, what they prefer and what they like. For example, if you use build to lossless, then we use 4:0 compression for the moving image, which adds color compression. So the red, for example, here could get duller because it gets blend in with the black around it. So it's duller than a lossless image. So if we build up a lossless image, you can see the colors start to pop out. So that can be annoying for some users. Some users don't mind. Others are very picky on it. So that's why I said check it with your customer. If needed, you can enable allow visually lossless, for example, or use visual quality high, which will probably use RLE for these lines as well. 3D CAD workloads, believe it or not, there's no optimized for 3D graphics here, because I would say build to lossless here as well. 3D CAD applications tend to have a lot of text on it as well. It's a mixed workload where you rotate a model, but you also pause the screen for a few seconds to do something. That's where I really recommend to build to lossless. It will give you a really good performance. And I would start with 30 FPS, but you can increase it to 45 or 60, for example, if necessary. Where optimized for 3D graphics really comes around the corner is for game developers and video editors. There you need a really fast performance, a full screen video codec. So here, again, use when preferred and then enable the optimized for 3D graphics, enable the hardware encoding, set the visual quality to high, and with AV1 preferred you will get the best quality. Otherwise use H265. Set the target frame rate to 60, but like I said, we can go up to 120 if necessary. For content creators, use when preferred, again, optimize for 3D graphics enabled, and set then build to lossless or allow visual, so always lossless, enable allow visually lossless, set the target frame rate to 30 or 60 depending on your use case. And with this use case, we can also support 10-bit and 10-bit HDR. So for interactivity, I really recommend going for build to lossless first instead of using always lossless. All right, I have 5 minutes left, so I just want to take you quickly through a few innovations that we've did recently for HDX, and particularly around user experience. So one of them, and I'm pretty proud of this one, is loss tolerant mode for graphics, which uses EDT lossy. And it ensures that the session remains interactive when there's packet loss detected. So seeing is believing in this case. So I hope this video plays well and it doesn't go into a weird mode here. So think about you're working from anywhere. You're in a hard spot like on an old platform and you have 10% packet loss. And you need to work on the 3D model of your old platform. In this case, it's pretty hard because the mouse is really lagging. Zooming in and out has a lot of lag. So if I stop moving my mouse, it will still continue rotating. So that interactivity is not great. So what if you would have a loss tolerant mode? So this is 10% packet loss on our latest VDA 2311. It's barely visible that there's any packet loss. So it's a really cool addition to our protocol, if you ask me. You can even see it here, hopefully side by side. So you can see that without EDT lossy, it's really stuttery. Oh, it starts to flicker again. Where on the right side, it's much smoother. So that's a really good enhancement, if you ask me. Another one that we added in 2311, but then in our workspace app, is to detect automatically what can the client device handle. So we talked about a lot of video codecs. And previously, you had to enable them via policy. But what if I have to bring your own device and you can't set a policy? So starting with 2311, we automatically detect what the client is capable of. And with that, we can negotiate with the server side which video codec to use. So we start with AV1, then H265, H264. So in this order, because AV1 gives the best performance and the best quality, H265 next, and if possible, or if nothing else is possible, we fall back to H264. So that really makes life much easier. So my last slide, because I know this was a lot of content, and I think I did pretty well on the time. A few lessons learned. Like I started with, the default policies are a really good starting point, and I would really recommend to start with them and start tuning from that point. But I told you about a few use cases, but still I would recommend you to test with your workloads and include your end users as well. Don't be afraid to ask them what they think of the quality or how they think you could improve it. What's their impression on the performance? And work together with them to optimize that user experience. And like I said, the GPU accelerates the encoding process because we can leverage the encoding chips on the GPU to use video codecs like AV1 or H264, H265. But also the entire stack just is accelerated by the GPU. And having a latest generation gives you the best encoding option. So if you buy the latest NVIDIA generation or Intel generation, you will get that ability to use AV1, which will give you so much more quality than using H264, for example. So I would really recommend looking into the latest generations if you're buying new hardware. Even though it might be a bit more expensive, you get the benefits, not only of better performance from that generation, but also the new video codecs that you can leverage. All right, and with that, I'm wrapping up, and I hope I'm still on time to answer a question if there's any, or otherwise, you can shoot me a message on Twitter or LinkedIn.